Yes, thank you, Amir. Good morning and good afternoon, everyone. My name is John David Lapinskas. As Amir's told you, I'm the technical director at Statera. It's interesting hearing the general introduction. You make me sound a bit like Moses. I've been around so long and done mostly everything related to environmental engineering. But I really look forward to this opportunity today to go over legacy waste. Why is legacy waste important? Well, that's kind of what I'm trying to go through in the next 30, 35 minutes, and why it's a responsibility to all of the major oil and gas players, all the blue chip players, to look at land restoration and groundwater restoration globally, for that matter. So we'll go through these slides. As I say, it'll run about 30, 35 minutes. If you have any questions at all, please put them through the chat. We're collating as we go through each of the presentations. So we'll kick off as we say. Haitham, and next slide. So this is the basic content of what I'll be getting across, as I say, in the next 30 minutes or so. A little bit of an introduction to Terra. We'll keep the commercial aspects down to a minimum. I'll be talking a little bit about the Saudi Green Initiative for to 2030. We'll be looking at, generally speaking, oil and gas sector legacy waste. Very, very brief session on pollutant chemistry, and then looking at the remedial technologies. This is really the crux of the presentation, looking at what both ex situ and in situ technologies are out there in the marketplace currently, particularly for KSA and GCC countries, generally speaking. Today's session is focusing on ex situ. And both of the companies that will be giving their talk, both Remedex and CDE, are undertaking at this point ex situ that we're talking about today. We will be in 2026 having a future webinar that will be discussing in situ technologies, things like soil vapor extraction, air sparging of that ilk. So keep an eye out for that one in 2026. And how we're going about this, generally speaking, again, is looking at soil and groundwater assessment for contamination, and then putting forward in a four-phase approach a remedial strategy to address those contaminants. Always, and of the most important in terms of what we're doing, are the environmental regulations that are out there currently. We're speaking strictly Saudi Arabia today. That's where we have our basis. We have operations running out of both Bahrain and Khobar. But we'll be looking at what the Saudi government has in place, particularly the Ministry of Environment, Water and Agriculture, MIWA, in something they call their executive regulations, and then the NCEC, and then as well the Royal Commission for Jubail and Yanbu, who've just brought out 2025 environmental regulations that I'll touch on very briefly in this presentation. And then obviously I'll be doing the conclusion portion that looks at what we've presented today. Next one, please. And again. So introducing Statera, well, Amir was the founding father. Amir, who's the managing director. The company was established in 2016, so we're all of about a decade, approaching a decade now. We carry out environmental services in soil and groundwater assessment, occupational health and safety, risk assessment sectors, but also we've just started up our sustainability division under the auspices of Dr. Ron Loughlin, and that's something we're very excited about moving forward with into 2026. Most of our work is in Saudi Arabia. We're also looking to expand into other GCC countries, Qatar, Oman, and the like. And we like to think we deliver comprehensive solutions, and it's all down to our motto, which is going beyond compliance, as that last bullet point clearly shows. Next one, please. So what are our ambitions as a company? We're looking to be in the top three, basically, environmental consultancies for the GCC countries, and we're now recognized as a major provider of environmental impact assessments, ESHAs, We produce environmental permits to operate and to construct, and that's the mainstay of what we do in our oil and gas sector, and then also in land development and other business sectors therein. Next one, please. Right. So again, just to ensure everybody has it clear, our motto is very special: to go beyond compliance. And what it means is we do embrace ethical conducts, strategic quality, and sustainability practices, and we've got a commitment to societal well-being, and hopefully which aligns with and exceeds the regulatory expectations of KSA. And it's more about cultivating a culture of, as we say, integrity. We like to think of Statera as a big family more than a corporate entity, and we've got a lot of quality people. And we ultimately create, we believe we create greater value on behalf of our blue chip client base. Next one, please. Again, we have Class A certification, which is important going forward. We have recognition from the Royal Commission and MIWA and the NCCC, as well as Saudi Aramco being a key provider of services to them, successfully completing something like about 24 projects with Saudi Aramco on the EIA front for their expansion and new build projects. Next one, please. And finally, we have a certificate of authorization to provide via the Royal Commission, who have a new logo, by the way, now, so we're probably going to need a new certificate. And also, we're very, very keen on cyber security, and this is something really important going forward. As everyone knows, it's a harsh world out there in terms of IT, and we've got to keep on top of our game to ensure client security in everything we do. Next one. Okay, and the next one again. And we'll talk a little bit about the Saudi Green Initiative, and we'll just advance those bullet points, please, Hatham. The SGI was it's an extremely ambitious national initiative that's focused on combating climate change, quality of life, protecting environmental aspects for future generations. I like to think of it more that we're not so much the owners of these resources as caretakers, because going forward, it represents handover of the most important resources to our children and our children's children. Coupled with that, the Saudi Green Initiative was brought about by His Royal Highness back in 2021, and something that is very near and dear to his heart. And I know that we've seen huge changes since the dissolution of GAMA back in 2020 and with the introduction of the NCEC. So basically, the Saudi Green Initiative is something that is really challenging and something that is actually taking hold, and they've achieved a lot of major milestones already. Next one, please. And these milestones are shown in these bullets, basically. So they're looking at something like 10 billion, that's with a B, trees to be planted in Saudi Arabia. We're looking at 30% increase in protected land. And that, most importantly, includes things like the marine and coastal ecosystems. We're looking at a 50% energy capacity change from fossil fuels to renewables by 2030, which is a major ambitious target to reach. And then 50 billion trees to be planted in the Middle East as part of a greening of both Saudi Arabia and the Middle East. And we're looking at an overall reduction of 130 million tons of carbon emissions, which all those are massive numbers and very ambitious targets. Next one, please. And again. Right. So let's kick off by saying, what's the definition for legacy waste? It's basically that waste that it has been around. I would imagine if you look at Aramco situation, started with Standard Oil back in the 1930s and 40s. So we've had 100 years of oil production and production of waste materials as well. And they can be such things as oil sludge ponds. It can be refuse. It can be various deposition of hydrocarbons that have not been treated originally. And this is not putting a blame on any one particular oil company. This was the environmental practice going back in the 70s. Things like oil soakaways, etc., which was not the best way to deal with hydrocarbon waste. Next one, please. So the definition itself, so we're looking at assessing and mitigating the risks associated with these historic waste dump sites and or hydrocarbon and contaminated leakages. Very important concept there, because the first thing you have to do is identify where the contamination is emanating from before you implement any remedial strategy. Why? Because you can't bail out the ocean at the end of the day. You have to correct the problem and then start looking at where it's the basic question of where, what, who, when, what is the hydrocarbon or what is the contamination in question? Where does it exist? What concentration is it in? How far does it emanate from its original source of leakage or spillage? And then thinking about a fundamental explanation that involves understanding that these sites may contain a mix of different soils and materials, and they can also include heavy metals and contaminants that can leach into the soil, and more importantly, into the groundwater. Just very quickly, I was in a lecture back when dinosaurs roamed the planet back in the late 70s in Germany, where one of the speakers was indicating that a liter of petrol or gasoline entering into an aquifer can contaminate a block of aquifer 1 kilometer cubed. That's an amazing stat, because it just shows that very little hydrocarbon can contaminate a great deal of groundwater. Next slide, please. Again, the description of legacy waste, it does show a picture of neglect. I mean, the photo in front of you shows that. It's something that is not very appealing to the eye, but more, it says in this particular one, it's talking about telltale signs. You don't, it's not a telltale sign. It's just massive contamination issues that need to be cataloged and addressed, and that's what we're pushing forward with. And actually, it's not just Statera. This is coming from all of the government regulatory bodies, that it's important at least to know what is the extent of the problem that you have. That's the first step before you do actually address the problem. And I'll be talking about how you actually, let's say, preempt the decontamination phase with an assessment phase. And that'll come in a few slides that'll follow shortly. Next one. And again, the legacy waste, it's a result of bad past practices historically. And again, this is an important line. The intention behind remediation is not merely cleanup, but it's restoring some kind of functionality to the degraded land, ensuring the safety of proximal communities, also site workers. So the initial phase of comprehension, it actually lays the groundwork for appreciating the complexity involved in the subsequent stages. Again, I'll be talking about that very shortly. Next one, please. And this is the key part here. So in terms of contamination characterization, there are different aspects to undertaking the remedial strategy. The first one is the most important, which is assessment. So you start off with things like desktop studies, moving on to intrusive site investigations, where you're actually taking soil and groundwater samples via either trial pitting or boreholing. And this lets you have samples that can be analyzed in the lab, and you can see the extent of your actual problem that you're dealing with. The types of remediation and strategy, as I said, today I'll be talking about ex situ largely, and our two fellow speakers on the remediation front will be talking about soil washing and bioremediation. Another pathway is to do stabilization of contamination in soil. And it really the overriding factor is strategic remedial planning. It's developing a detailed strategy, a robust strategy for adopting the best practice for the remediation of your problem at hand. Next one. So again, the initial remedial strategy, they focus on they can focus on containment, and this could involve, and this is a strategy I've seen a lot of petroleum companies use, which is capping the site either with clay or HDPE liner to actually prevent any infiltration of, in the first instance, precipitation, which can cause the underlying contamination to migrate further into the Vedas zone and then to the aquifer itself. It's not so much a problem, obviously, in KSA due to the lack of rainfall. But this is a strategy that is being used. It's not the best because basically what you're doing is you're burying the contamination, and it's site stabilization. But are you actually correcting the problem? Are you actually remediating that contaminant that's there? And that's the question I would ask. Next one, please. And again, this is going back to what I said earlier. A key factor in undertaking remediation of legacy waste is to have that initial delineation of the hydrocarbon in question, and to understand what the geological and hydrological conditions are. And that's often done through using things like ModFlow and eMod. These are programs that can measure the concentration of the contamination in the groundwater aquifer, and you can see the plume that's emanating from the initial apex of the contaminant in the bottom left-hand corner. So again, and what that second paragraph says it all, without a clear understanding of how the contaminant is moving, then you're not actually addressing it properly. So we're trying to address the contaminant at its highest concentration, but also throughout the actual plume itself. Next one, please. And this is something I got out of Arab News. It's effective in terms of a visual because it talks about soil and groundwater contamination. They're closely linked processes. Obviously, the contamination in the soil impacts that in the underlying groundwater. And it can actually can reach coastal. I mean, a lot of facilities that we deal with in KSA are coastally located. So you could have a hydraulic continuity between the groundwater aquifer and the actual sea or ocean in question. And there's a kind of a recharge back and forth of water, and that can impact the migration of a contaminant into the actual sea and affect coastal areas and the flora and fauna in the marine environment as well. So, and it says there's contamination can harm ecosystems and public health as well, poisoning potable water supplies and impacting food chain. Basically, it has great effect, both terrestrial and marine. Next one, please. Okay, it's very early in the morning, so I'm not going to tax your chemistry too much. Only to say, next slide, please. Hydrocarbons are key from what I've dealt with all my life in terms of oil and gas. Heavy metals are an issue, obviously. Norm waste is an issue. That's naturally occurring radioactive materials. Also, WE waste, which is having to do with electrical materials, wiring, etc., electronics. But from my standpoint, the key dangers lie within hydrocarbons. And amongst hydrocarbons, you're talking aromatics and what, if you remember from your chemistry classes, what are called alkanes. Uh, Things like, and I guess very simply put, things like lube oil have a very low solubility factor in water. So if you actually have a lube oil spill or a diesel spill, diesel has a solubility of something like about 4 to 6 milligrams per liter in the aqueous phase. So even if this material impacts the surface of the underlying aquifer, which is called the piezometric surface, it will just pancake out. It actually won't go anywhere, and very little of it actually goes into the groundwater. Whereas with aromatic compounds such as BTEC, so benzene, toluene, ethylbenzene, orthometaparazylene. These compact, which comprises about 50% of petrol, the makeup of petrol. And I just gave you the analogy earlier about 1 liter contaminating 1 cubic kilometer of groundwater. These are the problematic hydrocarbons that we have to deal with. Next slide, please. Yeah, and again, as I said before, I guess the worst case scenario for anyone who owns a hydrocarbon facility is to have a hydrocarbon release near a marine aspect, and you have a fish kill. And I've seen this before, where you can have thousands of fish wash up on a beach. And this is the implication of hydrocarbon hitting the ocean environment. It has massive disruption, and they can disrupt ecosystems, leading to biodiversity loss, dissolved oxygen levels dropping, and really creating a long-term issue for the health of the marine ecosystem. Next one, please. Again, I'm pretty well concentrating on hydrocarbons today, not so much heavy metals, but they come part and parcel with any industry or industrial sector. Some of the main ones, which are problematic, are both heavy metals such as cadmium, chromium, lead, but also metalloids. And that includes arsenic and mercury. I'm Canadian, so I'm very familiar with the problem that we have with mercury bioaccumulation in fish in the West Coast in British Columbia, where a lot of the natural native Indians are suffering from mercury poisoning because of the accumulation of mercury in actual salmon, and in particular in the adipose or fatty layers of the fish. And this is passed along the food chain. It's just something to keep in mind. Next one, please. I won't go too much in this, but obviously I mentioned about things like benzene and BTEX, but also it applies to volatile organic compounds. And also heavier polycyclic aromatic hydrocarbons, or what are called PAHs. They are extremely recalcitrant, and they can be problematic. I know our speaker from Remedex is going to talk about bioremediation, but PAHs are one of the chemical compounds that are extremely recalcitrant and difficult to biodegrade. In fact, there's some people have used fungus to degrade polyaromatic hydrocarbons. Why are they important? They tick all three boxes. They are carcinogenic, teratogenic, and mutagenic. So they are extremely a serious pollutant globally, and they're released through various sources: combustion, flaring, and from fugitive emissions from valves and storage tanks, etc., in refineries. Next one, please. And just the very last one on chemistry. This is a very old chromatogram I dug out of the catacombs of my technical library. I apologize for being a little bit fuzzy. It's the best copy I could get, but you can see it starts off here. It talks about gasoline being in the first range of hydrocarbons. So you're talking anywhere from the lighter ends, starting from about C4 or C5 pentane up through hexane, heptane, octane, nonane, and then you're into things like kerosene, and then C12 plus up to about C22 is diesel. These are all various what are called fractions of crude oil. So they're put through a fractional distillation unit at refineries, and you get various products coming off depending on temperature from the column. This is an important tool because you can basically take whatever contaminant that you find in the field, run it through what's called a GC mass spec or GCMS, and it'll come up and it'll tell you what that contaminant is comprised of. So when you see things like what is C fractions, C1 through C4 or C5 through C9, this is what they're talking about, the actual carbon chain fractions. And they can, as the first slide that I showed about chemistry, they can also be cyclic as well as straight change. Next one, please. And the very last labs in Kingdom, we've used various. The main ones that have accreditation with the NCEC and the Royal Commission are labs like, I guess, ALS, SGS. They're what are called MEWAM certified labs. They do a lot of let's say using blanks. Their protocol is according to APHA standard methods, and it's important to get a good lab. Analysis is not cheap. So again, your strategy for approaching your intrusive site investigation on site is extremely important. Next one, please. Okay, so now we'll start talking about the actual remedial strategies and methodologies that are available. Again, concentrating on what is called ex situ rather than in situ technologies. Next, please. Oh, sorry, I had this in the wrong order. It's the next category that I'm going to be talking about. This section again, we've mentioned it. How is it important in dealing with legacy waste? Again, it's a phased approach. So you've got four basic phases. Phase one is non-intrusive, so it involves a desk study and a site inspection walkover. So you're not involving any type of trial pitting or borehole installation. This is looking at historical information that's available and doing a basic site inspection walkover of the site. So it provides you with what we call a preliminary risk assessment. So it's more or less a qualitative assessment rather than quantitative. And this is the first stage of looking at evaluating a remedial problem that you have at any site. Next one, please. Right. So this leads on to phase two. So if it's established in phase one that the potential or potentiality for contamination is high, then it is recommended that you advance to a site investigation involving obtaining soil and groundwater samples, um, both at surface and discrete horizons down to the groundwater itself. And what's the purpose? The purpose is to provide samples that will enable you to carry out an interpretive analysis of the degree of contamination at that site. And again, what I said earlier comes back again, which is to know the location of that contaminant, how far does it spread both in the vertical and horizontal axis, what are you dealing with? Is it straight N alkane? Is it aromatics? Is it pH? So it tells you more or less what I refer to as the beast that you're dealing with, so you can come up with the most appropriate technology for remediation. Next one, please. Phase three, most important. So this is where you actually undertake pilot plant studies, where for the purposes of things like land farming and or soil banking, where you're doing it ex situ. So you've actually excavated the contaminant and you've taken it to an area where you're going to treat it. But first of all, pilot plant studies involving soil samples in the lab, where they're placed in columns and they're run for like 30 days to see the efficacy of using bioremediation strategy. So you're actually doing a trial on a very smaller scale. This also applies to in situ, where you're doing things like vacuum extraction. You do it over a limited area, say maybe 50 meters by 50 meters, to establish if that technology is effective, and before you actually go to the full-blown program, because this is where the money starts entering into the equation, because you're looking not just at capex but very long-term, potentially longer-term OPEX. And make no bones about it, a lot of remedial strategies they're not overnight solutions. They can take anywhere from between 9 to 18 to 36 months and more in actual soil treatment. Next one, please. And finally, we have phase four, where once you've got the system in place, it's been run. The most important thing is verification reporting. Why? Because you have to prove to the regulatory authorities that the strategy that you put in place is effective and working, and it does what you said you were going to do in the first case. Next one, please. And again. Okay, so I'm just looking at my time here. I've got about 10 minutes left, so I'm just going to skip through some of these final slides in terms of the remedial strategies, because we have two other speakers that will be giving you their particular method and some case histories. But what we're concentrating on today is ex situ rather than in situ. So again, it's away from site, it's excavated and brought to an area that can be treated in a controlled manner. By the way, this presentation will be available on the Statera website, so you can go back if you so choose to look at the details from each slide. Obviously, I'm not going to read all the text. It's they're important, what's there, but as I say, you can do this at your leisure at a later date. Next one, please. So stabilization, I talked about a little bit earlier. So very simply, it involves the use of what we call either pozzolanic or cementatious materials, basically Portland cement type things where you're mixing it with the soil to fix the contaminant in situ. This is kind of okay. I think where I have reservations is because it's only been used since about the late 90s. So we don't know what the long-term leaching effects are of the contaminant back into the environment. So I put a little bit of a question mark over this technology, but it's shown to date to be pretty well effective. Next one, please. Bioremediation, and we will have Philippe Couteau speaking on bioremediation from Remedex very shortly. This is a technology that is warm to my own heart. I've been using bioremediation. I first started using them building soil banks in Hamburg for Deutsche Shell back in 19, dare I say, 88, 89. Bioremediation is a really effective strategy. It's kind of a green strategy in so much that you're using natural ecosystem microbes to degrade your hydrocarbon contamination. Why? Because they see it as a food source. And as long as you get those conditions right of optimizing things like pH, actual temperature, moisture levels, oxygenation is such a key important factor, and nutrient availability, it's quite effective at actually degrading hydrocarbons. So this is one for the book. Next one. And part of the bioremediation, how you can employ it, things like biopiles, things like bioreactors, land farming. Now, land farming and engineered land farming, or enhanced land farming, as they call it, is a very simple strategy, and it involves using rotivators, adding nutrients, and basically rotivating the soil. And you can actually inoculate with bacteria, and they come in two forms, either freeze dried, or my preference is you actually take soil samples from, say, a refinery, and you can actually isolate strains of bacteria from that soil. Because why? Because they've been there for 50, 60, 70 years, and they've acclimatized to the hydrocarbon pollution, and they are your best candidates for actually undertaking bioremediation. You can grow them up in the lab and then reapply them during land farming or composting. Next one, please. And again, I will leave this to Doan to elaborate on. Soil washing, it's a remedial technique. It involves processing soil. It's extremely effective for certain types of soil, and the wash water can be treated separately, but I'll leave that for CDE to elaborate on. Next one, please. And again, ex situ thermal desorption, it has a place. It is effective because of the type of temperatures that you're using. So, how does thermal desorption? It's different from incineration because it runs at a lower temp. So it's running about 700 C, whereas incineration runs 1100, 1200. The downside of this technology is that it is expensive and it has a huge energy footprint. So you've got to think about balance at the end of the day. How much energy do you have to input to actually remove the contaminants? So it's something that I would put at the back of the line, but it is effective on almost every contaminant possible because it's complete destruction. Next one, please. And now this will be, as I said before, there's ex situ and in situ technology. I'm not going to even begin to look at this, but basically, what it's using various surface mounted equipment to draw to create a conal depression in the actual aquifer, and then you get deposition of any hydrocarbon in that conal depression, and then by a separate pumping, you can pump that to the surface. So it's actually always easier to treat contamination at the surface than it is in situ. But I'll be talking about this hopefully in webinar 4 in 2026. Next one, please. And this is a similar strategy. This is more for volatile VOCs, volatile organic compounds. And this uses both air sparging and vacuum extraction to move the contamination from the groundwater to the surface where it can be more easily treated. Next one, please. Right, and then again, problem identification. It's using all of these techniques to optimize your remedial strategy, and it has a lot to do with what it's going to cost you in the short and longer term. And as I've already mentioned, it's not just the capex of the original investment; it's the longer term operation of the system that can really be quite costly. But this is part of the parcel. I mean, a lot of companies have made a lot of money on the extraction and processing of hydrocarbons, and have left a legacy waste behind, and it's something that really should be addressed. Next one, please. Okay, so we're drawing towards the close now, and again, the meaning of remediation per se. It's about executing complex technical operations safely and effectively. The intention is to look at you don't want to look at longer term site remediation, but you certainly want to look at longer term monitoring to show that and demonstrate to the regulatory authorities that your selected remedial technology has had the impact that you were expecting. And again, it's all about establishing robust monitoring, and that's both for groundwater and for gaseous emissions from landfill, et cetera, et cetera. Next one, please. And again, the contaminant. If you take away one message from my section today, it's all about contaminant categorization. And as I said earlier, it's knowing what is the contaminant, where is it, what concentration is it in, is it going anywhere? It may not be. It may not be mobile. So it goes back to the old Dutch guidelines where they look at source, pathway, target, receptor. If it's not actually migrating, then the problem's limited to a specific area. If it is migrating, then you've got a bigger issue that you have to entertain. And as I said, you can go back and review this at your leisure. Next one, please. So very quickly on remedial costs, I haven't had a chance to amend the next slide, please. These were taken, I've said 2025, but I'll be honest with you, these are taken from about 2015. You can add, I didn't get a chance to revise these costs, but needless to say, they are more expensive, being we're going into 2026. But for all of these, if you look at bioremediation and let's say anything that involves non-processing of soil, other than soil washing, which is a strategy that is very effective for a great range of contamination. These are your general costs up until when you get to things like thermal desorption incineration, where the costs, as you can see at the bottom there, are almost prohibitive in the amount that you're actually being charged. Next one, please. And we'll just kind of finish up. This is the penultimate section on regulatory legislation. Next slide, please. So what are the environmental regulations in Saudi Arabia? They've got a framework that exists protecting air, water, and land resources. They look at things like emissions, wastewater discharges, waste management that may or may not involve the need for an EIA or environmental impact assessment. And it looks at polluted soil and groundwater remediation. Next slide. They very effectively, this is hot off the presses. This is the Royal Commission Environmental Regulations for 2025. I would highly recommend, if you're not familiar with them, to actually avail yourself of these three key documents. Volume one is everything you'd ever want to know about environmental regulations in Saudi Arabia, including the appendices, which concentrate, I think it's sections B, C, and D, or 2, 3, and 4, concentrate on emissions to air, aqueous discharges, and they look at, by the way, they look at compliance trigger values as well, and that's really important when you're looking at legacy waste remediation. Volume 2 looks at permits and licenses that are required, and you do require a specific license to undertake this type of remediation. We're proud to say, as Statera, we should be receiving our license very late this year, if not Q1 2026, to actually start undertaking remediation in Saudi Arabia. And volume 3 is the dark one that talks about penalties and fines for going above and beyond pollution in KSA. Next slide, please. And MIWA have two key documents for addressing legacy waste, and they are, as you can see in front of you there, they're available on the MIWA website. I would also suggest reviewing these as well, because they're very well thought out, and they give good strategies for remediation of contaminated land. Next one, please. And these are our conclusions, I'm glad to say, and hopefully I can do this in a couple of minutes to keep to my allotted time frame. Next one, please. So we're strongly affiliated with companies like Aramco, SABIC, Saudi Cayenne, amongst many others. And our function is to assist wherever we can in developing environmental impact assessments and to obtain their permits to both construct. This involves expansion of new facilities and permits to operate for either existing or new facilities. Again, it goes beyond just simple site facility assessment, but that's what we do. And we look at legacy waste, both organic and inorganic, and we do everything we can to assist in that regard. Next one, please. Part and parcel of everything we're doing, it ties in together. Sustainability and legacy waste actually go hand in hand. It's being responsible for the waste that's generated from everything from crude oil abstraction, either terrestrial or offshore, and then dealing with the associated waste from those processes. Next one, please. This is a mind blower. This is an oil sludge pond that I came across in Algeria. I'm not going to mention who the oil company was, but we're looking at I've got it up there. The actual diameter of that lagoon is 1.1 kilometers, representing 1.2 million cubic meters of contaminated waste. It's just mind-blowing. And this was taken from a Google Earth map. So that shows you and gives you some context as the extent of the particular problem potentially in the Middle East. Next one, please. And this basically, it kind of encapsulates what we've talked about. There's an issue with health with hydrocarbons. You're looking at pollutants which spread from soil into groundwater and potentially into ecosystems on the marine. And also, you have to be aware of the regulatory compliance that's required in KSA. And it's a cradle to grave responsibility. That's a very important phrase there that has been used for the past 30, 40 years. It basically says you shouldn't be passing along the responsibility of your pollution to a third party. It should be your responsibility. Next one, please. And that's the same, yeah. Okay. Something I came across very quickly. This was in Jubail. This was at a facility called BIA, which was processing hazardous waste. This is like Indiana Jones and the Lost Ark. It's it's unbelievable the amount of IBC containers containing hazardous waste that are waiting to be processed. This is the extent. This is the real extent visually of the problem that we're addressing. Next one, please. I love this photo. It's from the Pillars of Creation in the Eagle Nebula. It's something very important to my own heart. Legacy waste and everything that we do to improve the situation on the planet is something that we aspire towards. We invest in sustainable technologies. We're looking for the implementation of effective policies, environmentally speaking, and that requires an environmental awareness. And that's all part of the Saudi Green Initiative and fostering international cooperation. And hopefully Saudi Arabia can move towards a more sustainable and resilient future by this means. And just the last thing, renewable energy and fossil fuel are not mutually exclusive. I think there's a big push to go towards using renewable energy. Yes, but I think we have to be pragmatic in our approach. There's still 1.3 billion cars on this planet, and they're going to require petrol and diesel for some time to come. So it is a pragmatic introduction of renewable energy. So there's a balance. It's the yin and yang principle. Next one, please. And okay, that one I can skip. Again, it just shows you the degree of contamination present on some of these sites that is still to be addressed. Next one. And I just ticked on regulatory sustainability. So I talked about the legislation a little bit and what's required from both MIWA, the NCEC, and the Royal Commission. Next one, please. And this is, I think, the third or fourth slide before we finish. Again, remediation is something, as your takeaway message today, legacy waste can be remediated if it's addressed properly. And it takes a mature, educated, professional approach. Next one, please. Circular economy is something that's very present and a buzzword these days. It's part of what we're looking at in our sustainability division under Dr. Ron Laughlin. Next one, please. And cost, well, there you go. At the end of the day, it's kind of like pay me now or pay me later. I think if you address the remedial issue now, you're dealing with something that you can stop future pollution or the extent of the pollution, particularly in groundwater. Just as a last note, it's been estimated to actually remediate the groundwater in Saudi Arabia would come to something like 64 billion USD. Shows you that there is a lot of potential. There's a lot of need to actually address groundwater in KSA and in the Middle East, generally speaking. Next one, please. And that's, I think, the second last one. So again, sustainability is what it's all about. So addressing, and what I've just said, addressing legacy waste today ensures Saudi Arabia's oil and gas sector is prepared for future sustainability expectations. That says it all. And I think just coming up to the last slide again. So I don't know where I got this quotation from, but it says, "In every walk with nature, one receives far more than it's one seeking," which is really true. And you open up your eyes to things like legacy waste and realize the problem must be dealt with for our children and our children's children. And I think that concludes my presentation, and I will now hand back to Amir. Thank you, Amir.